Force vibration due to excitation of support, absolute motion. Dear friends, the force vibration due to excitation of support, harmonic motion. The absolute motion means its motion with respect to the coordinate system attached to the earth. Absolute means not related to other, or absolute is not a relation with the or comparative to other. Welcome to Kadam Academy. Dear friends, we have the number of videos on the mechanical vibration. Under this, we have covered the undamped, damped, and now we are going to study the force damped vibration. Under the force vibration, excitation of support. Under this, absolute motion. Part 1. Force vibration, base excitation, or the harmonic motion of support. Force vibration due to the excitation of support have the different applications. In this case, the car, jeep, truck, or bike, the aeroplane, of these vehicles or locomotives have the force vibration with the base excitation. How? This is the wheel base act as the base or support for the system, and that is also excitation is there, harmonic, due to this road unevenness. The wheel can move vertically up and down on the road surface during the motion of the vehicle. At the same time, there is a relative motion between the wheel and the chassis. So the chassis is having motion relative to the wheels, and the wheels having the motion relative to the road surface. See here, this wheel is having relative to the road surface, and this wheel is relative to road surface, and this chassis relative to this wheel. That is the relative motion and the absolute motion. For the absolute is what? There is no relation with the other one. Independently, when we calculate that, it is the absolute one. Right? These are the application for this one. Force vibration due to the excitation of the support. Now we'll see how to find out the amplitude of vibration in case of the support. Motion depends on the speed of the vehicle and nature of the road surface. The vibration measuring instruments are designed on the support motion approach. Such systems are supposed to have single degree of freedom for the simplicity of the mathematical expression. In a vibratory system where the support is having excitation, this earthquake, you can see here the earthquake is one more application, or this example where the maybe case happen for this base excitation. Example applications. Let's support, we'll see this locomotive already we have studied. This is one more example I will show you. This is a car with chassis and this wheel. They are having the relative motion, and this wheel having the with the surface, road surface, they are having a relative motion. This is the excitation of the base, or this is the example for the tractor. Here this is a suspension system in the tractor. Below this driver's seat, here you can see the front suspension and the rear suspension, and this which will be give this clear idea related to the damping and the mass is there M1, and the damping and spring system which will reduce the vibration due to the road surface. We'll see one example. Compare this tractor, how the tractor will be compared. This is a kubota. This is a vibration test challenge. Glass of water is kept on this tractor, and there are various tractors of different companies. You can observe clearly. This is the John Deere tractor. The same speed is maintained during this the vibration. Getting the clear the idea how the vibration of different factor. The engine is started and it is moving with a high speed. This is joined here. Kubota, Japanese tractor company, Kubota. See, it is very less as compared to other Kubota, having the modified suspension system with the good suspension. They reduce the vibration and that will be good feeling for the driver, comfort zone for the driver. Swaraj, the tractor with the Swaraj, see how the response. This is a farm track company's tractor. See how the response is there. Swaraj 855 XM. Dear friend, these are the just to show you the examples for this vibration test challenge. Now we'll see the how the base excitation support we have to derive or how to calculate the amplitude for this type of this condition. The absolute amplitude we are considering. Here is the spring mass damper system. The mass spring and this damper is there, and this support is having harmonic motion with the displacement y is equal to amplitude capital Y into sin omega t. Sine wave, it will move with the sine wave. That may be support or that may be base. In case of the automobile, you can see the base. Okay, so this is the two example for the base and the support. This equilibrium position after this base displaced position for the base with this movement of y, and here is the mass also displaced with this distance of x having the same velocity x dot and the acceleration x double dot. So what will happen? This will move in a upward direction when the base is in the direction upward side. So this is the FBD diagram for the in this case, and this is the support. Here is the support with the harmonic excitation, and this is the FBD diagram with the, here you can see clearly this displacement in downward direction and acceleration in the upward direction, and it's shown in this diagram to get it the equation of motion. To find the vibration of force vibration due to the base support excitation absolute motion, in this case this is the diagram. For this we are going to calculate the absolute amplitude. Calculate this value of x for this mass. What is the amplitude of capital X? This terminology will see in short. The x is the absolute displacement of the mass in m. Y is the absolute harmonic displacement of the support in meter. That y, small y is equal to capital Y into sin omega t. Capital Y is the amplitude of the vibration of the support in meter. X, capital X is the steady state absolute amplitude for the mass, and omega is the angular frequency. You can say angular frequency for this y. What is the applied harmonic excitation? For that purpose, what is the angular frequency? Small m is, this is the mass of the body in kg, k is the spring stiffness Newton per meter, and c is the damping coefficient Newton second per meter. This is the terminology we are using here. Steady state absolute amplitude we are going to find out. For this, let x be the absolute displacement. Already we have considered for the mass m then the equation of motion from this diagram, the D'Alembert principle we are using, that mx dot is always in the opposite direction that considered, and the summation of all the forces, that is a mx double dot, this one, and they are in upward direction, they are taken positive plus sign k into x minus y, as there is both the displacements are there, x and y, x displacement minus y, or c can be coefficient here, this is also both displacements are there, and as there is velocity we are considering for the damping, the x dot minus y dot. So friends, here is the equation, we can put it the value in this equation or just solve it and rewritten this equation, mx double dot kx, the cx dot, these terms are written on one side and the y terms are written on this side, dy dot and the ky written on the right hand side and left hand side. This equation is as the support is subjected to harmonic vibration. So this y is equal to capital Y sin omega t. Y dot, that is the dy by dt with respect to t. Then that will the equation differentiating this equation, y into omega cos of omega t. So putting these values of y and y dot in this equation, it is like this: mx double dot plus cx dot kx dot is equal to ky sin omega t plus cy, this y dot here omega into cos omega t. So friends, this equation already we have here. Up to this it is clear to you. Now one term is added here. One term is what? Which term? Under root of k square plus c square omega square. Same term is added here in the below this k, and this c omega upon this one. But where from this term is come? This term will come from this triangle. As we know, the spring and this damping coefficient, they are in 90 degrees with each other. From this force polygon diagram, we can write this one, the under root of k square plus c square omega square. This we introduce in this equation, and we can write for this term and this term here sin alpha c omega by under root of k square plus c square omega square. Here we can replace for sin alpha, and for this cos alpha is equal to k upon the k square under root of k square plus c square omega square. From this triangle we can write this relationship. Let's then assume this and we have put in this equation, we get the, but one more thing, this tan alpha is equal to sin alpha upon cos alpha, the tan alpha is equal to c omega by k. So alpha we can find out from this one, tan inverse of c omega by k. Find the tan inverse of this 2 into zeta omega by omega n. Just c omega by k replace with this term. How? This c omega by k we can replace by using this relationship. This, we know this c upon cc we written here, and cc it may be cancelled, but we have introduced this term cc upon 2m and again 2m upon k. This c, what was our c omega k? Just we introduced these two terms cc and 2m in this equation, and from this relation and this 2m by k, m by k means what? 1 upon omega n. So omega by omega n is m upon k, 2 is remaining 2, and this term we can return here this term we can return here zeta, 2 zeta omega by omega n. Then what will happen here? So this zeta term is here omega n square, and this term again omega n. So this term is omega n and 2m by omega n square. So this omega n and this omega n will get cancelled. What is the remaining? 2 zeta omega by omega n. So like this c omega by k is converted in this form to zeta. Just simplifying from this we can calculate directly the values for the alpha, and just putting this one in this equation, this term as this term k by 2 here, this equation becomes like this. After simplifying and solving this in the manner, the mx double dot plus cx dot plus kx is equal to y under root of k square plus c square omega square into sine of bracket omega t plus alpha. So friend, so this is the equation, the complete solution of this equation in harmonic force condition. What will happen? In this case, x is equal to xc plus xp. xc plus xp. The absolute displacement of mass from the equilibrium position x, you can find out xc by xp. So xp is nothing but the x sine omega t plus alpha minus alpha phi. This, in this condition, this xp equal to x sine omega t minus, inside the bracket, just rewriting this equation, phi minus alpha. So just comparing with the harmonic excitation for the without the motion of the support. Okay, this harmonic excitation for the previously already were completed in one video, that is the force vibration with the harmonic motion. Friend, this is the equation for that condition. Mx double dot cx dot plus kx is equal to fo and omega t. So in this is a steady state condition in base and support subjected to harmonic vibration condition can be written now. This mx double dot plus cx dot plus kx is equal to y and root of k square plus c square omega square sin omega t plus alpha. This is the one equation of motion for the steady state, or in case of the base support excitation. The upper equation is nothing but the absolute differential equation of the motion, which is similar to equation of harmonic force. This equation is equal to, just comparing these two equations, this equation and this equation. So these terms are remain same. This FO we can write this, replacing the FO is equal to this term y into under root of k square plus c square into omega square. So this is just comparing these two equations. What way you can write? The FO is equal to y under root of. Now x can derive the value of x. What the x? That is the amplitude, absolute amplitude in this harmonic force condition in the base excitation. In previously harmonic force condition, already we have calculated the value of x. So watch the video for that to clear you the how to calculate the excitation, the amplitude for the harmonic excitation. Fo by k upon under root of 1 minus omega by omega n square bracket square plus 2 theta omega by omega n, this bracket square. This is denominator and this is numerator. Just replacing this FO in this case for the support excitation. This x is the steady state absolute amplitude for the support and is subjected to harmonic vibration can be written here. X is equal to, just replacing the FO in this case is y into under root of k square plus c square omega square upon k. Here k is written and this denominator is same, similar to this one, previous harmonic motion. Now we can find out this value of x. This x is nothing but your amplitude, absolute amplitude. But this c omega square by k, if we k is taken inside this under root, so this k square get cancelled and c omega square or c square omega square upon k square, this term we can write like this, 2 zeta omega by omega n, the bracket square. So it will become like this. This equation now, x is equal to y into under root of 1 plus 2 zeta inside the bracket, the 2 zeta omega by omega n bracket close is square upon denominator. This k we had taken common In both the case, you have taken common, and this will be this one. And here in denominator written as it is 1 minus omega by omega n square bracket square plus 2 zeta omega by omega n square. And this is the final equation. The y we have taken on this side, and x by y is equal to, we can write like this. In the numerator, the under root of 1 plus 2 zeta omega by omega n bracket square, under root of this bracket, first bracket 1 minus omega by omega n square bracket square plus 2 zeta omega by omega n bracket square. So this is the form, one of the form of this steady state amplitude. Friend, this ratio of x by y is called the displacement transmissibility, which is ratio of the steady state absolute amplitude of the body mass to the absolute amplitude of the support. The support displacement, absolute displacement, and this is the mass displacement, absolute displacement. So this ratio, from this we can also write the phase lag. We already studied alpha is equal to tan inverse of 2 zeta omega by omega n. Just we'll go in detail for this phase lag, that is the difference between this phi and alpha. So this motion of this mass lags that of the support. Motion of mass lag that of the support. So we can see the phi is for this mass alpha, already we calculated. This phi minus alpha is the phase angle. In this case, the phi minus alpha is the phase angle. This phi we can calculate by using this, already derived this phi for the harmonic motion, force vibration harmonic motion, you can see. And this phi minus alpha, here it is written phi minus alpha is the phase lag for this case. The transmissibility ratio versus transmissibility curve also we can draw for this model for the transmissibility for the harmonic motion. For the, here is the support is not in motion, and for this case already we have studied the transmissibility ratio and transmissibility curve with respect to frequency ratio omega by omega n, which is equal to r. This already we have covered in one video, and this same similar to the, in this case this ratio, this curve are similar in both the case. Okay, so I want to just conclude with this, do some information to you for absolute amplitude versus frequency ratio x by y. This formula we know, and this is drawn on this y-axis 1 2 3 4 5 6, and x-axis 1 2 3 4. Okay, and you can already studied here under root of 2. We can conclude for the following points for this figure. Here at the frequency omega by omega n, here ratio, frequency ratio omega by omega n under root of 2 for all values. Here you can see here all values of damping. This graph with respect to damping, it will change. Okay, zeta, it will change. All the dampings of the amplitude ratio at x by y is unity. Here 1, all the damping, here is the unity for this frequency ratio, and the amplitude ratio is less than 1 for all the values of the damping when omega by omega n is greater than under root of 2. See, is below 1, x by y ratio is below 1 for all the ratio greater than this, zeta is greater than under root of 2. Under root of 2. Okay, this ratio here you can observe 2 3 4, any ratio, this will be less than the 1. For high values of frequency, omega by omega n is greater than, much greater than 2, it will tend towards the 0. Ratio is quite small, for which means the support displacement almost negligible. Support displacement is almost negligible. For high values of frequency ratio, omega by omega n is much greater than the under root of 2. The amplitude ratio is quite small, which means that the support displacement is almost negligible. For high values of frequency ratios, damping ratio does not have any important role so far as the amplitude ratio is concerned. Lastly, regarding the phase lag or phase angle is not 90 degree at resonance. In such case, force excitation, you can observe this figure here, is the phase angle phi minus alpha on y-axis and x-axis omega by omega n, and this is the already we have discussed in the frequency curve video. Watch that video to clear your ideas. And this is the relation between these formulas, comparing the formulas, equation for the force vibration and the excitation of the support with absolute amplitude. What is the equation for the motion? mx double dot cx dot kx fo sin omega t. mx double dot cx kx is equal to y into k under root of 1 plus 2 zeta r square sin omega t plus alpha. These are the two both equations, and similarly they are compared with this xpx and the phi xpx, and here phi and alpha. Here the mf is the magnification factor. Here the mf is the magnification factor. We can write magnification factor already we have 1 upon this term is mf into y, k get cancelled, and remaining will be the this term, numerator term, under root of this one, that is the mf y under root of 1 plus 2 zeta r square, that is nothing but the ex amplitude for this excitation of the mass. Okay, the amplitude, absolute amplitude. Phi alpha we know, as we know this phi minus alpha is the motion of the mass lag, that support of the support by phi minus alpha. And here is the complete derivation for this understanding of this harmonic motion with the base excitation of support with the harmonic motion. So friend, thank you for watching my video. You always learn by self-assessment only, and write down the 3 takeaways from your learnings of the video. And if you are not subscribed for updated video, please subscribe my channel. Thank you very much.